Welcome everyone to another lecture on programming in C++. So today we are going to talk about different features of object-oriented programming, and also our main focus will be on the classes and objects. We are going to understand how classes and objects are being implemented in C++, how instance variables and member methods are written in a class definition, and how a class members can be accessed using objects of that particular class. So let's get started. One, two, three. Action. Any object-oriented programming evolves around the concept of these objects. So these objects are trying to imitate real-world entity. So what could be a real-world entity? So for example, we can take an example of account, bank account obviously, as a real-world entity. And this account can have some properties as well as some behavior. So properties could be like account number, customer details, and it has some behaviors like credit, debit as well. So this credit and debit are behaviors or the functions, and this account number, customer details, amount, so they are the data or rather properties of this account entity. So what object oriented programming does, the object oriented programming tries to mimic this real world entities into software environment or software objects. So they try to create software objects, uh, and this software objects is nothing but a collection of data plus functions, and these functions actually operate on this data only. That means in real entity as well. So if we take the operations or behavior of bank account, it could be credit and debit. What on which data it could apply this credit and debit option? So this will be applied to this amount. So the data and the functions that are associated on or operated on that particularly data are combined together to form a software object and try to mimic whatever operations or whatever real world entities actually does. So other parts of the code cannot access this data except that particular function. So those functions that are operating on that particular data, that means credit and debit, except credit and debit, no other operations can actually perform or can be done on this amount or account number or customer data. Or if we have suppose say employee. So employee entities or anything from employee cannot actually do something or do any operations on account number, customer details, or amount. What they have to do, they have to go through this bank account. So they have to enter the bank account, or they have to go through this bank account, and then only they can access this method, this data or this properties of bank account using the methods credit and debit. So only credit and debit has the direct access on this data. So that is the case in case of any object oriented programming. And objects communicate with one another by sending and receiving information to each other. So as I said, so if the employee wants to update these values, he has or he or she has to go through this bank account data or bank account entry to actually use this method credit and debit to update the amounts of a particular account number. So employee cannot directly actually change the amount of any account. He or she has to go through this bank account details, then only it can access this credit and debit. So employee cannot directly work on this amount. He or she has to use this credit or debit function to operate on this particular amount. So let's look at the features of or any object oriented programming. So object oriented programming has several features like classes and objects. So these two are called the heart of OOP. So these two actually forms the main concept of OOP, and along with the abstraction and encapsulation, and the other properties or other features of object oriented programming are polymorphism and inheritance, and we are going to understand each of them uh, in the following slides. So the building block of C++ that leads to OP is a class. So classes and objects are the main concept or main funda that is behind any object-oriented programming. And the building block of any C++ programming is actually this classes. So classes are sometimes known as user-defined data type. That means like structure and union in C, the classes can be considered as a user-defined data type. And what classes has? So a class is consist of nothing but some data along with some functions that operate on this data. So which holds its own data members and member functions. So this data, so whatever data is inside the class is called data member, and whatever functions that are actually operating on this particular data are called member function. And these member functions or data members can only be accessed by creating an object of this particular class. So no other object or objects of different class cannot access the data member of a class. So if suppose this is class A, so only the objects of class A can access the data and function data members and functions of this particular class. No other object can be, or no other object or object of some other class cannot access the data and the function. So classes can be considered as a similar group of similar type of objects that shows similar behavior and properties. Classes are also called the blueprint of an object because objects are created from the class, or objects are like variables of class type. So that's why objects are sometimes referred to as the blueprint of the class. So for example, we can consider a class cars, and there may be many cars with different brand names, uh, different brand and different model numbers, but all of them will share some common properties, like all of them will have four wheels, speed limit, mileage range, etc. So here car is a class, wheels, speed limit, mileage are their properties. So they have some similar properties, like I said, and these are the properties. So what will be the operations or what will be the functions on this car? So how to accelerate, how to stop the car, that could be the functions of this car as well. So this car is a class. If car is a class, the wheels, speed limit, mileage are the properties of that particular class. So classes are user-defined data types which has some data member and some member functions. So it will be something like this. So we have the class. So this is our class. It has some data members and some member functions. And these data members can only be manipulated by this member functions, no other function. So if we have some function from here or any outside the class, they cannot operate on them. Only the member functions of that particular class are allowed to operate on them. And these data members define the properties of real world entity, as we have seen in the previous slides, and as well that member functions actually defines the behavior of the class. So for example, in our previous example of car, we can say that the data members are the speed limit and the mileage, whereas the member functions could be apply brakes, increase the speeds. So from this we can conclude that a C++ class is a blueprint of similar type of group which share some common properties and behaviors. So this is what a class is in object-oriented programming as well as in C++. So the object is a identifiable entity with some characteristics and behavior. So these characteristics is actually the data, and behavior is actually the functions. So these functions can only operate on this data. So a object is called an instance of a class because it is created from an class. So all the objects are have to be defined using a class. So when a class is defined, no memory is allocated. So whenever we actually define a class in C++, memories are not allocated uh, for the data. Whereas whenever we actually create an object of that particular class, memory is actually being allocated. So when a program is executed, the objects interact by sending message to one another. So the objects actually interact with each other. So one object or different objects of different class can communicate with each other using some messages that is called the message passing. So objects take up space in memory and have a associated address like structure or union. So objects are actually work as a variable of class type. So class becomes user defined type, and objects actually becomes, you can say, a variable, or we can consider it as a variable of class. Or we can also say objects are a representative of a class. Like you have a class, class in the sense in your college or in your school, you have some class. So from that class, if you pick one student, that student will become the representative of the class. So objects are something like this. Like from a group of similar kind of behavior and property, we have chosen someone that will represent that particular group. So that is an object. Each object contains data and code to manipulate the data. Data and code to manipulate the data. So that is the same. The data that will represents the properties of that particular object or characteristics of that particular object, and whereas the code or the functions will manipulate that characteristics. So objects can interact with having to know uh, details of each other's data or code. It is sufficient to know the type of the message accepted and type of the response returned by the objects. So two different objects, say obj1 and obj2, can communicate with each other without knowing the implementation details. That means what are the actual data residing in this object 1 and what are the actual data residing in this object 2, that is not needed to be understood by both of them. They can only understand what type of message they are sending, so type of message, and what is the output they are getting from there uh, as a reply. So that is enough to communicate between two different objects. So how classes and objects are defined in C++. So let's look at the syntax first. So a keyword called class. This keyword, class keyword, is used to define a class. So class keyword is followed by the class name. So this is a user defined name, or you can say user defined identifier. So class name identifier that is used to represent that particular class. So this class keyword will be followed by this class name, and we have an opening brace and a closing brace. So inside that we can write some data members and some functions. So this is how we can declare a class, and declaration of class definition ends with a semicolon. Whereas to create an object, what we have to do, so it is similar to this type where. So this statement is similar to type where. So what we are trying to do, we are trying to create an object of class. So we have to put the class name with the object. So let's look at this particular example here. So we have created a class called room that has some data and some uh, functions that operate on this particular data, and we have created two objects of this room, so room 1 and room 2. So for now, just forget about this public. So this is called access specifier. We will come into details about this. So they are called access specifier. So they actually handle how this data are being treated in in So this access specifier actually uh, controls how these data members and member functions are being uh, handled or are being accessed by outside the class. And this is how we have created two objects of this class room. So what we have here, we have some three datas: length, breadth, and height of a room, and we have two methods that one calculates the area and another one calculates the volume. So these two methods can be operated on this and produce some result or return some results from this function or through these functions. So encapsulation is one of the important concepts in object-oriented programming. So if we just simply say what is encapsulation, encapsulation means wrapping up of data and the information under a single unit. So what actually it means in object-oriented programming? Object-oriented programming, it is means by binding the member variables and member functions together. So that is what we learned in class, right? So actually, class is used to implement this encapsulation concept as well. So encapsulation is defined as binding together data and functions that manipulate them. So what we are trying to do, we are trying to actually encapsulate member functions. And encapsulation also leads to data abstraction and hiding. So we are just about to get to know about data abstraction and hiding. And one more interesting thing is that we have two different sections here: private and public. So private means, so if a data member or function is private, that will be restricted from outside the class. Whereas if it is public, it can be accessed from anywhere, but through an object of the class. So this public member, so whatever the public members is, can be accessed from anywhere outside the class, but you have to use a class object for that. Whereas if we have some private members in your class, you cannot access them from anywhere. So let's take a look at some real world examples. So suppose there are three sections in an office. So suppose we have an account section. So we have an account section, we have some finance section, and we have some sales section. So they have their own data, they have their own data, and they have their own data, and some people who are managing this data. So suppose in some scenario, this one of the salesperson or one of the salespeople requires some data from the finance. So what they can do, this people or they cannot actually access the data from the finance directly. There is no way they can access the data from the finance directly. What they have to do, they have to consult with a people from this finance. So one of the people from the finance will be consulted by the person that wants the finance data. uh, so that person will contact this one of the people from the finance, and that particular person or that particular function actually going to return that particular data that is desired by this people in sales section. So they cannot have a direct access. That is why data and the functions that are operating on the data are encapsulated together so that no one from outside can access them directly. They have to be accessed through some functions within that particular class, within that particular uh, group. So this is encapsulation. That means we can actually bind data members and functions together. Also, they can be hidden from the outside world as well. So to hide them, we use a concept of access specifier. So two of the access specifier are private and public. There is another one is called protected. So we are going to talk about them as well. So data abstraction. So what is the data abstraction? Data abstraction means suppose we have something. So we have some implementation details here. So we have some implementation detail and outside we have something suppose. So to the user, we are only showing this information because that is this information is relevant to the user. User is not actually capable enough to understand what are the implementation of this particular object is. So abstraction means displaying only the essential details and essential information and hiding the details. So all the details are being hidden from this particular user and only it can see the essential information, that is the information that is essential for that particular user. So refers to providing only essential information about the data to the outside world. So only the information that is actually helpful for the user will be given to the user and other things will be hidden from the user. So hiding the background details or implementation, that is abstraction. So abstraction means hiding all the details and only just showcase what is important to that particular user. So we can take example of man driving a car. So that man only knows the pressing the accelerators will increase the speed of the car or will stop the car. So he or she or that particular man doesn't know how this actually happening. So how when you press or when you apply the acceleration, how the speed is being increased, that is not important for that particular man. And how when you apply the brake, the car is stopping, that is not actually required to know for that particular man or for that particular driver. But a car engineer or whoever builds the car, he or she actually needs to understand how this is happening or how that when you press the accelerator, the speed is being increased or how we apply the brake, the car will stop. So these details are essential for the engineer, but these details are not essential for the driver or the man who is driving the car. So this is how actually in real life we can say data abstraction everywhere. In C++, there are two ways for data abstraction. So abstraction using classes. So using classes, we actually hide the details of the data and only showcase whatever we require to show and that are specified using the access specifier. So as I said, public and private. So public specifier is used whenever we want to showcase something to the outside world of the class, and private access specifier is used when we don't want to showcase anything from the class to the outside world. So a class can be decided whether which data will be visible to the outside world and which are not. So that is done using this access specifier that we are going to learn next. And abstraction is also happening in header files. So consider this situation: whenever you need to use some operation, power operation, you use this method that is written in math.h header file. So whenever you need to calculate the power of a number, simply we actually or you actually call this power method, right? That is from math.h header file. But what we actually do, we pass the arguments like pow, say a comma b. So it will calculate a to the power b. So it will give us the result of a to the power b. But we are not aware how it is happening or what is the background processing is done while applying or while getting that particular value from this power function. So we are not interested in that. We are actually interested in that we have to give some input and it will give us the result. So this is one of the abstractions that are used in C++. So there are two types of abstractions that are used. used or that are available in C++. One is using classes, another one using header files. Now, let's move into the concept of data hiding. This is very much important concept. So, from encapsulation to data abstraction, you have seen this term data hiding and access specifier. So, what is happening here? Data hiding is hiding the details of internal data members of an object. So, the internal data members of an objects are hidden, and that is the concept of data hiding. So, hiding the data, that is one of the important feature of any object-oriented program, because data needs to be secure. So data hiding is also known as information hiding. Sometimes data hiding includes encapsulation. Thus, data hiding is heavily related to abstraction and encapsulation. That from the previous slides, we have already understand that data hiding is one of the important concepts of abstraction as well as encapsulation. And data is actually managed by access specifiers within the class. So there are three different access specifiers: private, protected, and public. So what they does? So private members, so this can be accessed only from within the class members with the same class. That means if we have a private member, it has only visibility to this particular portion. That means no one from the class can actually see what is happening in the private members. So protected members, this is a bit complicated, but for now you can consider is as private as well. So this can be accessed only from within the class members of the same class and its derived class. So what is derived class? So we are going to talk derived class when we are talking about inheritance. So derived class is a class that can actually inherit some of the properties from some old classes. So that is a derived class. So at that particular situation, protected members actually helpful. So public members, so these can be accessed from anywhere where the object is accessible. So what we can do, so if we have some public members in the class, they can be accessed from outside the class, but you have to use an object. For that, the class definition becomes something like this. So we have this class keyword again and the class name, and we have the braces, that is the class block where we define some data and some function. But now what we have to do, we have to specify either private or either public, or in case of if we are using the properties of inheritance, we can specify the protected members as well. But if we are not using inheritance, then there is no need to specify anything protected. So we can use the private members and public members as well. So what will happen? We have to write. So suppose, for example, we can write class ABC private and then a colon. So this will specify that everything afterwards will be a private member. So suppose we have int a, and then you can specify public. So this will specify that after this everything will be the public. That means everything will be visible to the outside world. So suppose print cout, sorry. So this is an example of a class where we have used private data members as well as public data members. So int a, this is a private data members, and print, this function is actually public. So that means we can actually access these public members from outside the class using an object. So we have to define ABC, say A1. So using this particular object, we can access this particular function. But as it is a private member, we cannot access that particular object from outside the class even using the object of the class. But if we want to access this print function out from outside the class without using an object, that is not possible. Even though they are public, they can only be accessed through an object only. That means in the sales examples that I said, that only a finance person can give us the return data or the data from the uh, finance department. No one other or other persons or other person from different departments cannot access the data directly. So similarly, only an object of this ABC class can access this public member. No one is able to access these private members from outside the class. Then another important concept on of any object-oriented programming is polymorphism. That means having many forms. So it gives us the ability to a message being displayed in more than one form. That means, for example, a function can operate, or a function with the same name can operate differently if the input to that particular function or the arguments to that particular function is different. So operations may exhibit different behavior in different instances. The behavior depends upon the type of the data. So consider this plus. So if you put an integer here and integer here, so what is happening? It will produce an integer result. But if you give a float number here, float number here, it actually producing a float result. So that means the plus operator, the same plus operator, depending on the data, whatever we are giving to the data, or whatever the data we are giving to that plus operator, it produces the result according to that. So that is polymorphism. Similarly, same function, suppose two area functions are there, one takes one input, another one it takes two inputs. So two area functions can have or can produce different result. That means they calculate the area but of different uh, structures or different shapes. Like if we take one input, it can compute the mm, area of a circle. If you have given two inputs, it can compute the area of a triangle. So we are going to look into those examples later. So what is happening? Polymorphism is exists in real time as well. That means a person at the same time can have different properties. A man at the same time is a father, a husband, a employee. So when that particular man or the particular person is in office, he is an employee, whereas he is in house, he is a husband or a father. So the same person processes different behavior in different situations. So whenever the situation is changing, the behavior of that particular person is changing. So that is polymorphism. So polymorphism in C++, we can see that operator overloading and function overloading are there. So function overloading is using a single function name to perform different tasks. So like we have this particular situation, so where we have given two inputs as an integer. So this function will return a plus b, like sum of these two numbers. When we give three numbers, it will return the sum of three numbers. So this particular option was not available in C. Like in C, we can't have two functions with the same name, but in C++ we have this facility, and we have some restrictions as well. We are going to talk about that later. So but we have that facility where we can actually uh, have functions that has same name, because they actually operate, they actually does the same thing. But what is different? The difference is the data they are operating on, the result they are producing. And also operator overloading is also there. That means the concept is that so class is a user defined data type. That means objects are variables of that class. Whatever operations or whatever operator is actually applying on normal data, or like integer, float, and all these things should be applicable on those objects as well. That's why C++ has provided a mechanism for operator overloading. Like we can overload this plus operator to add two objects. So object 1 and object 2, because the plus operator, the general nature of plus operator is to add two values, and they could be any values like int, float, double, and all these things. So for that you can, or we can, or the programmers can write actually or overload this plus operator to add two objects as well. So these are the two examples or two areas where actually polymorphism is applied in C++. So there are some other areas as well. We are going to explore them when we are going to learn polymorphism in details. Then we have this inheritance. So this is the capability of reusability. So reusability is what the basis of this inheritance. The capability of a class to derive properties and characteristics from another class is called inheritance. So it actually based on the reusability. Inheritance supports the concept of reusability. So what is happening here? So suppose we have a class called animal class. So if you want to create a new class called dog class, so there might be some properties uh, that can be inherited or that can be used that has been written in animal class already. So that is how the concept of inheritance is coming. That means we are going to write this dog class and we are going to use some data from the animal class, and we are going to write our dog class adding some new features, new behaviors or new properties as well. Like here dog, cat, cow, all of them has some similar properties like four legs, two eyes, two ears, one tail. So these properties can be copied from this animal class, so we don't have to write those properties again and again. So similarly, cat class can also be inherited from animal class, and cow class can also be inherited from this animal class. What could be different? Cow produces milk, that is different from these two. So all animals cannot produce milk for humans, actually for eating. uh, so this is how inheritance actually works. So inheritance means we can actually use some of the data or some of the codes that is being previously written, uh, and we can create a new ones or new classes from those previous classes, and we also can add own new features in this classes. That means new features can be added here, new features can be added in this derived class. So this particular class in this particular example is called the super class, and this particular classes, all of them are called the subclass. So the concept of superclass is the class whose properties are inherited by subclasses is called base class or superclass. So this is called base class or superclass. So in this particular example, animal class is the base class or superclass, and subclass, the class that inherit properties from another class, is called the subclass or derived class. So this is what a derived class is. So for this example, dog, cat, and cow can be derived class of animal base class. So this is how actually inheritance works. We are going to look into the details of inheritance and how they are being implemented in C++ in later classes. So stay tuned for that. And another important concept is message passing. Like we have some object one, we have some object two. So suppose for all these functions are defined in the private section of this classes, and sorry, public sections of these classes. So what can these objects do? These objects can actually communicate with each other through these functions. So they cannot directly access the data of these other objects, but they can actually communicate with each other using this particular function. So that is message passing, and message passing is essential for any object oriented programming, because two objects or two classes cannot communicate with each other without the messages. So message passing is very important. So objects communicate with each other, sending and receiving information to each other. A message for an object is a request for execution of procedures. Whenever you actually try to uh, send a message to another object, so it is basically is a request of executing a procedure, and will invoke a function to receiving objects that generate the desired result. So we are going to call a particular function from another class or another object, and that will generate some output based on whatever operations they have performed. So this message passing involves the name of the object, the name of the function, and the information to be sent. So how it looks like? So it is look like something like this. Say object dot function and arguments. So this is how a message could look like. Object dot function arguments. That means this object is trying to invoke this particular function with this information. So this information will be passed to this particular function, and some operations will be happening uh, on on behalf of this particular object, and some results will be generated for this particular message. So let's talk about how we can access members of a particular class. So this is interesting. So we have this setup. So we have this class box. So class box, we have some public data, that is double length, double breadth, and double height. So we have three different data. So one to represent the length of the box, another one to represent the breadth of the box, another one to represent the height of the box. Now why we have put public here? Because by default, inside the class everything is private. So if you don't specify any access specifier, by default everything will be private. So whenever something inside a class everything is private, that class is basically useless, because no one can use that particular class. Even if we create an object of that particular class, that class or the members of that particular class cannot be accessed anyhow from those objects as well. That's why we need some public data, at least one public data in all the classes, so that it can communicate with the outside world. So in the main function, what we have done here, we have created two objects. So object 1 and object 2. So box 1 and box 2. These two objects will be initializing, or will use or will access their data members and try to assign some values on those data members. So for accessing a data member, we use an operator called dot operator. So this dot operator is used along with the object. So what is the syntax of accessing any data member? So it is object, then dot member. So this is the way how we can access a particular object or a particular member of a class through the object of that particular class. That means to access this length, breadth, and height of this class box, we have to create objects of class box, and uh, that can be used to access the length, breadth, and height of this class. So we have defined a volume variable, double variable volume, and we now want to specify all the specifications of box 1. So for box 1, we have said box 1 height is equal to 5.0, box 1 dot length is equal to 6.0, box 1 dot breadth is equal to 7.0. So somehow it looks like a structure operations as well. So this particular example, in this particular example, as we don't have any functions, it actually looks like some structure operations in C. And then we are going to specify the box 2. So box 2 height is equal to 10, box 2 dot length is equal to 12, box 2 dot breadth is equal to 13.6. And then we are going to try to calculate the volume of box 1 and volume of box 2. And what will happen? So what we are trying to do, we are trying to find the volume. So volume means length multiplied by breadth multiplied by height. So to access the height and length and the breadth, we have used these dot operators along with this box 1 object. That means what is happening, so whenever you specify these values, or rather whenever you declare this particular values, what is happening in the memory, we have two objects now. One is b1 or box 1, another one is box 2, and also these variables, these data members, they are also called data members, are also called instance variables. They will have their own space, like we have length, we have breadth, and we have height. And both of these boxes have their own length, breadth, and height. That means they have their own instance variables. So here also we have length, we have breadth, we have. So what is happening here? So whenever we are assigning this box 1 dot height 5.0, in the box 1 it is happening 5.0, 6.0, and 7.0. So this is happening on box 1, and whenever we are trying to specify box 2, so box 2 dot height, this is 10.0, 12.0, 13.0. So this is how two objects are being specified in the computer memory, and whenever you are trying to apply this formula, box 1 multiplied dot height multiplied by box 1 dot length multiplied by box 1 dot breadth, it is calculating the volume of this box 1, printing that result, and then we go into uh, the volume of box 2. So box 2 dot height, box 2 dot length, box 2 dot breadth, and then we are printing. So the output will be something volume of box 1 is whatever the volume of this 210, and volume of box 2 will be whatever the multiplication of these values are. So 10 multiplied by 12 multiplied by 30. So whatever value will be that, that will be the output of this particular function. Sorry, particular program. And also you must assume that we have hash include is IO stream and using namespace. So let's talk about member function. So a member function of a class is a function that has its definition or its prototype within the class definition like any other variable. So suppose the previous class box. So in private section, suppose we have some data, and in public section we can write our functions. So it would be something like this. So all the classes ends with a semicolon. So mind that. So you have to end the class with semicolon. So class box can have some private data, or any class can have some private data and some public functions. So some functions can be private as well. So generally, this is the general formation of any class where the data are being hidden from the outside world, and the functions that can actually operate on this data are visible to the outside world, and the functions can only be accessed using the object. So what these functions does, so these functions actually operate on it operate on any objects of the class on which it is data member. So on this particular data members of some objects, these functions actually working and has access to all the members of the class for that particular object. So if you have some object of class box, so suppose box b1, so this b1 through these functions can access all the members of this class. So b1 will have all access to all the members of that class regardless of they being the private members or they being the private public members. So this is how a member function works. So how can we define a member function? So there are two different ways to define a member function. One, you can only write the prototype of the function inside the class. So we have this class box. We have taken again the public members of this data, and we have also this public member of this function. So there are two ways. Either we can actually define these functions within the class. That means we can write the function definition as well as the function prototype, or we can only specify the function prototype. And these functions, this member functions are no different from the ordinary functions. The ordinary functions also have the same architecture or same structure. Like it has the return type. So this is the return type. This is the function name, and in between the braces we have this uh, argument list. So this is no different from ordinary functions that we have learned in C. The member functions, what is only different? That these functions are defined within the class. That means within the class definition, we have the class definition. So there are two different ways to actually defining the functions. So we are going to talk about them in the next class. Uh, so how can we access this function? So after defining this particular function, what we can do, if we have a object of box class, what we can do, v1 dot get volume. So similar to accessing the data members, we can access the public functions of a particular class using the dot operator again. So dot operator is called the member access operator. It is used to access any member regardless of it is a data member or it is a member function. Doesn't matter if you have some functions in public section of a particular class, you can create an object of that particular class. You can use the dot operator access that particular member of that class or that particular member function of that particular class. So, we are ending this class here. In the next class, we are actually going to a deep dive into the details about member functions and how they can be created, how they are defined, and also we are going to learn some more topics regarding classes and object. Thank you.